Assalamualaikum. We are from Group 36, exercise 1 under uncontrolled rectifier.
Assalamualaikum warahmatullahi wabarakatuh. My name is Norman Bisenu, DE190173, and for Lab 1 uncontrolled rectifier, I will show the simulation for activity 1. First, we need to insert the AC voltage for this circuit. We must insert the AC voltage with 100 volt peak and 50 Hz frequency. After that, we must insert one diode in the circuit with two resistors. The first resistor is a 100 ohm resistor, while the other one is 1 ohm variable resistor. And don't forget to put the ground in the circuit. Then we must connect all the components as shown in the lab sheet before we can start to find the value of VAC, Vmax, Vout and Iout. So after we have finished with the circuit, we can find all the value that has been mentioned earlier. So the first value that we want to find is the value of VAC, which is by using a multimeter. So we can run this circuit to find the value. So this is the VAC and this is the multimeter, so we can find the value of V with AC is 70.9969 volt, and the value of ampere is 7.069. So we have find the value of VAC. Now we must proceed to the Vout and Iout using a multimeter. So this is our Vout and Iout, and this is the multimeter that we use to find the value of Vout and Iout for this circuit. So we have run, and this is our Vout. So the value of our Vout is Vout AC, which is the RMS for this circuit, which is 37.84 volt, while the ampere is the Iout is 71.76 ampere. So we have find all the three values of VAC, Vout, Iout using a multimeter. Now we proceed to find the value of Vmax using a oscilloscope. So we must stop this first, and we must delete this connection before we can start to do the simulation for Vmax. So we have connect with our load, which is our load, and this is our graph. So we can stop first this graph, and we must set the division so we can see the graph. So as we see in the graph, this is 15 volt per division, which is this is 100 volt. But we can see here that this is actually 97.85, which is not fully 100%. Now for the last one, we need to find the waveform for our Vout and Iout inverted, which is this part. So what we need to do first, we must connect this oscilloscope to find the voltage, the Vout. After that, we must find the Iout. So we need to use this component, these tools. After that, we must connect it with our channel B, and this is to the ground. After that, we can stop and run again. And this is the first we must stop it, and then set the division. So this is too big, so we make it smaller by increasing the value of division, same as the channel B. Increase the division. So we can see here that channel B is our Iout and channel A is our Vout. So this is the waveform for our Vout and Iout inverted. So we have find all the values in this activity 1. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurshani binti Abdul Halim. My metric number AE1900045. I will present you about the activity 2 in exercise 1 for Power Lab. Okay, for the design 1 for R1 and L1 inductor resistor we run. For Vmax, we take here the value at here that we got 31.418, and this for V out the 38.883. Okay, so for current out, we take 75 for 426. Sorry, 426. And we stop. And for L1, L2, R1 that we arrange in series circuit, we run there. For wave, for oscillators. So I don't get. Oh no, sorry. Okay, stop. Alright. So for design 2, that we are here our circuit. We run this mission. For V max, we take this 30.787, and for V out we take 39.114, and for I out we take 75.413. Okay, for third circuit we must run, and we get this wave for second. Okay, for third circuit we got this, and we on the diode. So for the Vmax we get 38.304. Okay, and sorry, V out we get this, and I out we get from this. Okay, that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Putri Balkis binti Amran, and I will explain on activity 3. Okay, so this is the activity 3 instructions. Okay, first of all, we have to construct the circuit based on figure 1.3. Okay, this is how it's supposed to do. I'm also using multisim apps. Okay, first this is the AC voltage with 100 volt and 50 Hz of frequency. Then this is the bridge rectifier, and then this is the resistor with 100 ohm, and this is the control resistor which is 1 ohm, and I connect the oscilloscope here and the multimeter. Okay, then we have to run to get the graph and the readings. Okay, so this is the graph that we get, because this is only the per cycle, positive cycles. So to get the both cycle, we have to connect it with, we have to make another connection with channel B. Okay, like this. And okay, so this is how we get the connection. We just need to, okay, just like this. And this is how we get the both cycles. This is the first one, and this one is the second one. So we just want, this is the first one is the V out. Yes, this is the V out, and this is the V in. So for the multimeter reading, okay, this is the I out. The readings is 30.215 ampere, and the other one is for Vmax. Vmax is okay, this is the Vmax, 61.931 volt, and for the V out, the 30.329 volt. Okay, for the VAC is actually the maximum amplitude. We can just take it off with just like this. Okay, we have to get the readings. Okay, here. Okay, make it 0. Okay, forward position. Okay, to get the maximum amplitude, we have to read it like this. So this is like 97.366. It's almost 100. So we can just write 100, or just get the readings by the amplitude, or the peak of the amplitude. So that's all for the simulation for activity 3. That's all from us. Thank you.